UTP connectors. UTP cable is usually terminated with an RJ45 connector. This connector is used for a range of physical layer specification, one of which is Ethernet. The standard describes the wire color codes to pin assignments or the pin out for Ethernet cable. Types of UTP cable. Different situation may require UTP cable to be wired according to different wiring conversion. This means that individual wires in the cable have to be connected in different orders to different sets of pins in the RJ45 connectors. The following are the main cable types that are obtained by using specific wiring convention: the Ethernet straight-through, Ethernet crossover, and the rollover. The Ethernet straight-through is the most common type of the networking cable. Ethernet crossover is a cable used to interconnect similar devices, while rollover is a Cisco proprietary cable used to connect a workstation to a router or switch console port. Testing UTP cables. After installation, a UTP cable tester like the one shown should be used to test for the following parameters: the wire map, cable length, signal loss due to attenuation, and the crosstalk. Fiber optic cabling. The properties of fiber optic cabling. Optical fiber cable transmit data over longer distance at a high bandwidth than any other networking media. Unlike copper wires, fiber optic cable can transmit signals with less attenuation and is completely immune to AMI or RFI. Fiber media cable design. Optic fiber is composed of two kinds of glass, core and cladding, and the protective outer shield, which is the jacket. Each component in the figure, although the optical fiber is very thin and susceptible to sharp bends, the properties of the core and cladding make it very strong. Optical fiber is durable and is deployed in harsh environmental conditions in networks all around the world. Types of fiber media. Light pulses representing the transmitted data as bits on the media are generated by either lasers or light emitting diodes or the LEDs. Fiber optic connectors. An optical fiber connector terminates the end of an optical fiber. A variety of optical fiber connectors are available. The main differences among the types of connectors are dimensions and method of coupling. Testing fiber cables. Terminating and splicing fiber optic cabling requires special training and equipment. Incorrect termination of fiber optic media will result in diminished signaling distances or complete transmission failure. Fiber versus copper. There are many advantages of using fiber optic cable compared to copper cables. So, given that the fiber is used in fiber optic media are not electrical conductors, the media is immune to electromagnetic interference and will not conduct unwanted electrical currents due to ground issues. Optical fibers are thin and have relatively low signal loss and can be operated as much as greater length than copper media. Some optical fiber physical layer specifications allow length that can reach multiple kilometers. So, purpose of the data link layer. The data link layer. The data link layer of the OSI model is responsible for allowing the upper layers to access the media, accepting layer 3 packets and packaging them into frames, preparing network data for physical network, controlling how data is placed and received on the media, exchanging frames between nodes over physical networking media such as UTP or fiber optic, receiving and directing packets to an upper layer protocol. Last is the performing error detection. Data link sublayers. The data links layers is divided into two layers, the logical link control and the media access control. The logical link control, this upper sublayer communicates with the network layer. It displays information in the frames that identify which network layer protocol is being used for the frame. While the media access control or the MAC, this lower sublayer defines the media access process performed by the hardware. It provides data link layer addressing and accessing the various network technologies. Media access control. The layer 2 protocol specifies the encapsulation of a packet into a frame and the techniques for getting the encapsulated packet on and off each medium. The technique used for getting frame and on and off the media is called the media access control method. Providing access to media. Different media access control methods may be required during a single communication. Each network environment that packets encounter as they travel from local host to remote host can have different characteristics. For example, an Ethernet LAN consists of many hosts contending to access the network medium. Serial links consist of the direct connection between only two devices. The data link layer standards. Unlike the protocols of the upper layer of the TCP/IP suite, data link layer protocols are generally not defined by requests or comments. The Internet Engineering Task Force maintains the functional protocols and services for the TCP/IP protocol suite in the upper layers. The IETF does not define the function and operation that models network access layer. So for topologies, the controlling access to the media. Regulating the placement of data frames into the media is controlled by the media access controlled sublayer. Media access control is the equivalent of traffic rules that regulated the entrance of the motor vehicles into a roadway. The absence of any media access control would be equivalent of vehicle ignoring all the traffic. Physical and logical topologies. The topology of a network is a range or relationship of the network device and the interconnection between them. LAN and the WAN topologies can be viewed into two ways, which is the physical topology and the logical topology. The common physical WAN topology. WAN are commonly interconnected using the following physical topologies: the point-to-point, hub and spoke, and mesh. Point-to-point, this is the simplest topology that consists of permanent link between two endpoints for this reason. This is a very popular WAN topology. Hub and spoke is a WAN version of the star topology, which is a central site interconnects branch sites using point-to-point links. Mesh is a topology provides high availability but requires that a very end system be interconnected to every other system. Therefore, the administrative and the physical costs can be significant. The logical point-to-point topology. The end nodes communicating in a point-to-point network can be physically connected by a number of intermediate devices. However, the use of physical devices in the internet does not affect the logical topology. The physical LAN topology. Physical topology defines how end systems are physically interconnected. In shareable media, LANs and devices can be interconnected using the following physical topologies. Half and full duplex. The half duplex communication is both devices can transmit and receive on the media but cannot do so simultaneously. While the full duplex communication is both devices can transmit and receive on the media at the same time. The data link layer assumes that the media is available for transmission for both nodes at any given time. Media access control method. Some network topologies share common medium with multiple nodes These are called multi-access networks. Ethernet, LAN, and WANs are example of a multi-access network. So the frame, the data link layer prepares a packet for transport across the local media by encapsulating it with a header and a trailer to create the frame. Frame field, frame breaks the stream into separable groupings with control information inserted in the header and trailer as values in different fields. This format gives the physical signal a structure that can be received by nodes and decodes into packets at the destination. The layer 2 address. The data link layer provides the addressing that is used to transport the frame across a shared local media. Device addresses at this layer are referred to as physical addresses. The LAN and WAN frames. In a TCP/IP network, all OSI layer protocols work with all the IP at OSI layer 3. However, the layer 2 protocol use depends on the logical topology and the physical media. And that's all for this chapter number 4. And thank you. So hi everyone, we're back with a new video, and for this video we're going to summarize this given chapter, which is the chapter 4, the network access. So let's start. So the physical layer connection, types of connection, where you're connecting to a local printer in a home or website in another country. Before any network communication can occur, a physical connection to a local network must be established. Physical connection can be wired connection using a cable or a wireless connection using radio waves. Network interface cards. Network interface cards, or the NIC, connect to a device to network. Ethernet NIC are used for a wired connection as shown in, whereas WLAN, or the wireless local area network, NIC are used for a wireless, and end user devices may include one or both types of NICs. A network printer, for example, may only have an Ethernet NIC and therefore must connect to the network using an Ethernet cable. Other devices such as tablets and smartphones might only contain a WLAN NIC and must use a wireless connection. The purpose of the physical layer. The physical layer. The OSI physical layer provides the means to transport the bits that makes network media. This layer accepts a complete frame from the data link layer and encodes. It is a series of signals that are transmitted onto the local media. The encoded bits that comprise the frame received by either an end devices or an intermediate device. Physical layer media. There are three basic forms of the media. The physical layer produces the representation and groupings of bits for each type of media as copper cable, fiber optic cable, and the wireless. Copper cable, the signals are patterns of electric pulse, while fiber optic cable uses the signal are patterns of the light, while wireless, on the other hand, is the signals are patterns of microwave transmission. The physical layer standard. The protocol and operation of the upper OSI layer are performed in software designed by software engineers and computer scientists. The services and protocols in the TCP/IP suites are defined by the Internet Engineering Task Force, or the IETF. The physical layer consists an electronic circuitry media and connectors developed by engineers. Therefore, it is an appropriate that the standards governing this hardware are defined by the relevant electrical and communication engineering organization. So, the bandwidth. Different physical media support the transfer of bits different rates. Data transfer is usually discussed in terms of bandwidth and throughput. Bandwidth is the capacity of a medium to carry data. Digital bandwidth measures the amount of data that can flow from one place to another in a given amount of time. Bandwidth is typically measured in kilobits per second, megabits per second, or gigabits per second. Bandwidth is something thought of the speed that bits travel. However, this is not accurate. For example, in both 10 Mbps and 100 Mbps Ethernet, the bits are sent in the speed of electricity. The difference is the number of bits that are transmitted per second. The throughput. Throughput is the measure of the transfer of bits across the media over a given period of time. Due to a number of factors, throughput usually does not match the specified bandwidth in physical layer implementation. Many factors influence throughput, including the amount of traffic, the type of traffic, and the latency created by the number of network devices encountered between the source and destination. Types of physical media. The physical layer produces the representation and groupings of bits as voltages, radio frequencies, or light pulses. Various standards organizations have contributed to the definition of the physical, electrical, and mechanical properties of the media available for different data communication. This specification guarantees that cables and connectors will function as anticipated with different data link layer implementation. As an example, for copper media are defined for the type of copper cabling used, bandwidth of the communication, type of connector used, pin out and color codes of connection to the media, maximum distance of the media. So for the copper cabling, the characteristics of copper cabling. Network use copper media because it is inexpensive, easy to install, and has low resistance to electrical current. However, copper media is limited by distance and signal interference. The copper media. There are three main types of copper media used in networking. The unshielded twisted pair, the UTP, unshielded twisted pair or the STP, and the coaxial. The unshielded twisted pair cable is cabling is the most common network media, or the UTP cabling terminated with the RJ45 connectors is used for interconnecting network hosts with intermediate networking devices such as switches and routers. The shielded twisted pair cable or the STP provides better noise protection than UTP cabling. However, compared to UTP cable, STP cable is significantly more expensive and difficult to install. Like UTP cable, STP uses an RJ45 connector. The coaxial cable. Coaxial cable or the coax for short gets its name from the fact that there are two conductors that share the same axis, as shown that the coaxial cable consists of a copper conductor used to transmit the electronic signals, a layer flexible plastic insulation around a copper conductor. The insulating material is surrounded in a woven copper braid or metallic foil that acts as the second wire in the circuit and as the shield for the inner conductor. The second layer or shield also reduces the amount of outside electromagnetic interference. The entire cable is covered with cable jacket to prevent minor physical damage. The copper media safety. All three types of copper media are susceptible to fire and electrical hazards. Fire hazard exists because cable insulation and sheets may be flammable or produce toxic fumes when heated or burnt. Building authorities or organizations may stipulate related safety standards for cabling and hardware installation. So for the UTP cabling, the properties of the UTP cabling. When used as networking medium, unshielded twisted pair cabling consists of the four pairs of colored-coded copper wires that have been twisted together and then encased in a flexible plastic sheet. Its small size can be advantageous during installation. UTP cabling standards. UTP cabling conforms of the standard established jointly by the TIA and the EIA specifically. The stipulates the commercial cabling standard for LAN installation and is the standard most commonly used in LAN cabling environments. Some of the elements defined are cable types, cable length, the connectors, cable termination, and the method of testing cable. UTP